So this session is going to be about well-architected, really trying to answer the question, are you well-architected? Because as we see, failures happen all the time, and so how do your systems or your processes respond to those? So just to make this a bit more interactive, because all I can see is a sea of blue lights from headphones, is who here is building technology solutions and feels that their teams are building something that is well-architected, that's following best practices? Hopefully most people, they've got great teams. Most people feel reasonably confident, okay. Now, when you ask that question, people feel a little bit less confident when you ask them, well, do you feel confident in that when you think about all of these different areas? So maybe some of those areas would make you think, hey, my team's great, but we want to dive a little bit deeper into how they thought about security or reliability. One thing that can help you feeling more confident about whether you're building well-architected systems is to review your architectures, is to have a conversation about the systems you've built and work out whether it's been following your best practices. Of course, doing that in a consistent fashion can be difficult. The person who's involved in reviewing the architecture may have had a bad evening with their football team, and so they might not be reviewing the architecture the same way that they've reviewed other architectures. Or maybe they've got a focus on security, so they'll dive deep on security, but maybe don't feel so confident about asking about reliability. And when I talk to most customers, it's rare that they thought about applying a consistent process across their whole technology portfolio. How do you make sure that all of the systems you're building are following some level of best practice? And so that's why we created AWS Well-Architected, is to help customers understand if they're following best practices, and of course then be able to make informed decisions about how you might address anything you see in there that you might want to improve. So let's talk about the history of well-architected. So well-architected has been around for a number of years. It actually started in 2012. AWS solutions architects started having conversations with customers asking, hey, well, is this approach to building this architecture well-architected? And we've evolved that over a number of years. One of the things I'd really like to emphasize is that well-architected is about AWS listening to customers and looking at what is working for them. And so the best practices that we talk about evolve and change over time. So this is not a fixed point in time. This is the best way to build a system. We're looking at what's working, new technologies, how things are evolving, patterns and practices, and building that into well-architected. And in 2018, we released the AWS Well-Architected Tool, which you can use in the AWS console to review your architectures for free. So as much as possible, we try to give you not just a framework for reviewing architectures, but also the tooling for doing that process as well. So what is the AWS Well-Architected framework? I like to think about any kind of system or process in terms of why, starting with why. And in this case, what kind of benefits do customers see from using well-architected? So when I talk to customers about the benefits they see from carrying out well-architected reviews on their architectures, they see these kind of benefits. So for example, they can build and deploy faster. And that happens because well-architected emphasizes using automation to build systems. So you spend less time doing manual processes and have human error, and have more time with systems which are repeatable, evolvable, and hopefully high quality. One way to think about well-architected is a mechanism for your cloud journey. So as you move from working in an on-premises environment and you're starting your cloud journey, well-architected helps you to learn what the best practices for building in the cloud are. One of the things that well-architected gives you, which as an engineer I've always looked for, is a way to measure architectures. Is this architecture following best practice? Is it any good? And so that's one of the key value offerings from doing well-architected, is it gives you a way of reviewing an architecture and give you some sort of measure of how well it is following best practices. And of course, when you've done that measurement, you then have the opportunity to improve that architecture. So we also provide you with advice on how you can improve the architecture based upon those findings. So what is the well-architected framework? Effectively, it's a set of questions and design principles across 5 pillars. One way to think about that is to think about when you're building technology solutions, it's a lot like constructing physical buildings. If you're building any kind of physical construct, such as like the Excel Center, you really have to think about the foundations of that building. Because if those foundations are not solid, then it's going to be hard for that building to be safe and easy to use, but also it's going to find it hard to deliver on what it's intended for. So if you don't have good foundations, you might build that library, it won't be safe, and it won't be a great place to read books. And a similar thing when you're building technology solutions. If you neglect the 5 pillars that we identify in the well-architected framework, security, reliability, performance efficiency, and cost optimization, and importantly, how you're going to operate that system. One of the things we see is that when people build systems, they don't necessarily think about on day one, am I designing this for operations? So you have to think about how you're going to also operate it. So if you think about something like the Excel Center, it's not just enough to think about its physical construction, you also have to think about how is it going to be used. And as you'll see with most technology solutions, you'll put a lot of time and resource into the design phase, but the runtime will actually dominate your costs and the value of that system. So you really want to put effort in from day one on thinking about how that system is going to be used. So how are people applying well-architected? One of the things we like to do at AWS is to create ways of doing things that customers can choose how they apply them for themselves. And what we've seen as a recurring pattern of success are these 3 things. Firstly, people who are successful using well-architected use it as a way to have a conversation about how do I improve my architecture. They don't use it as an audit process, so it's not about blaming someone about the mistakes they've made. It's really about a consultation on how do I look at this architecture and how can I make it better. Secondly, the other thing that we do is we make sure that well-architected is pragmatic. So all of the advice in well-architected is based upon experiences of real customers running real systems on AWS. So this isn't based upon people thinking in ivory towers about the best way to run architectures. This is really about, have we seen customers be successful with this? And so hopefully when you're reading the well-architected framework, you'll see that the advice is based upon things that you've also seen being successful as well. And finally, I would say the other thing we see is if you use well-architected as a continuous process. So if you're thinking about a product lifecycle, using it early on in your design phase, and as your product matures, helps you to continue to look at your architecture and work out how you can improve it. What you don't want to have is a static architecture which you have to rebuild every few years because you haven't continued to evolve it. And so the well-architected framework allows you to turn that into more of a process. So how might I go about reviewing an architecture? And here you have choice. So this has evolved over the years. So one of the things you can do today is that you can go into the AWS console and you can review your architecture using the well-architected tool. And we built that to be an educational experience. So as much as possible, we've tried to put the learnings of how to build good architectures into that experience. So we won't just help you answer the questions, but we'll also try and give you advice on how to understand how we think about this question, the kind of things that are important, and the kind of concepts that you might need to understand. And so you can use the well-architected tool in the console for free to review your architecture. And of course, the advantage of that is that you can review whichever workloads you want, when you want. So a good example of that would be that customers might review an architecture early on in the design phase. And then as they're building that system and they make design decisions, they can just go back into the tool, change that one question, and then carry on. And we also give you the ability to create milestones so you can see how your architectures are improving over time. Your next choice is that you could use a partner. So we have select APN partners who we have trained on how to do well-architected reviews, how AWS solutions architects think about architecture, and how we review architectures. The advantage of this approach is that obviously everyone's busy. Who here is not busy? Put your hand up. No one. Everyone has more work to do than they can possibly do. So an APM partner can help you bring in extra resources to work on your systems. And critically, if you find issues with those systems, they can be hands on keyboards and help you fix things. So this can be a great way to actually move forward in terms of your architecture, continue to deliver features, but also address some of the issues that might be slowing you down. And then finally, you could talk to an AWS solutions architect. Now, this is on a best efforts basis, so a solutions architect can sit down with you and review your architecture. We recommend you use that for your critical architectures, or when you want to have a conversation about the thematic issues you might see across your workloads. So imagine you reviewed 5 or 6 of your different architectures running on AWS. You could then identify that maybe there's some issues you're seeing that are a repeating pattern, and is there any training or anything that AWS can do to help you address that more holistically? So we're going to be talking today about a real-life example about how a customer worked with a partner to improve their architecture. And I wanted to explain to you how that model works before we dive into the actual example. So firstly, you can engage with an AWS APN partner. There's a list of the current ones on the website up here who can carry out well-architected reviews. And they will review your architecture for free. So effectively, they'll review your architecture and work out where there are places where you could make improvements to that architecture. And they'll write you a statement of work of things that they would improve. And of course, that will cost money to have those statement of works implemented. So if you're trying to justify making that happen, what AWS will do is that if you agree to have that partner fix those issues, that AWS will give you $5,000 worth of AWS credits to offset the cost of doing that. And that's because AWS wants to see you succeed in building and running systems. Ultimately, if you're successful, then you're more likely to be working with AWS, and we're more likely to see you continue to exist as an organization, and it gives us more opportunities to work with you to make architectures better. So I'm going to switch over now to give you a real-life example. So I'm going to ask Phil to come up from Steamhouse, and he's going to talk about how they worked with one of their customers to improve their architectures. Phil.
Hello, everyone. Thank you, Fitz. So, as Fitz said, my name is Phil Horn. I'm from an advanced consulting. No sound. Okay. Any sound yet? Good sound. Right. I'll start again. So, hello everyone. Thank you, Fitz. My name is Phil Horn. I'm from an advanced consulting partner based in Manchester. We've been a well-architected partner for about the last 18 months. During that time, we have run about 20 reviews with customers, some existing customers, some new customers. And as Fitz said, what I wanted to do today was come up and tell you a little bit about how we go about them and a real-world customer story. So over the course of those 20 or so reviews that we've done, we've established 3 common reasons, 3 drivers for why people typically take up a review. The first of those is some sort of disaster, some sort of security issue or stability or costs running wild and the business needing to get a bit of control on that. Others can be sort of tactical, sort of short-term type reasons, for example, peak trade or some media event that's about to come up, and the business wants to get some confidence in its platform and in the preparations that it's made to get through that particular peak event. And the third typical one that we see is something a bit more strategic, looking a bit longer term, and a business knowing that they're about to embark on a new phase of that business, some major change in the business, and again, wanting to get confidence that the platform that they have in place is going to serve that business as it goes into its next phase. So the business that I decided to tell our story about is this business called CanO. Anyone raise your hands if you've heard of CanO? Brilliant. Okay. Now, this room is full of people, and the people watching the presentation, full of people that should feel a great deal of affinity for this business. Their mission, their reason for existing in the world is to teach kids how to code. Okay? As it says on the slide there are more than 20 billion devices, connected devices around the world today, and yet there's a tiny, tiny percentage of us that actually knows how to understand and influence them. My own personal story in this is I've got 2 little kids, 9 and 11 years old. I bought them a CanO kit, I gave them the box, and 45 minutes later, they were there working with the kit and coding with it. If you haven't got a CanO kit, and I'm not getting commission, but if you haven't got a CanO kit, you definitely should have one.
Okay, so CanO are a good story, apart from being a really inspiring business to work with. CanO are good because they are an example of two of those drivers that I was talking about before. They were going to market peak trade, so before Christmas last year, with a new product that they were doing in association with Harry Potter. So they have a coding wand, which actually allows kids to cast magic spells and code those spells themselves. So very cool, but also an exceptionally high-profile brand that no one really wants to have any sort of disaster with. So they wanted to bring us in so the engineering team at CanO wanted to bring us in to just sense check the preparations that they'd put in place themselves for going through that peak trade event. And it wasn't just Black Friday. Their bigger concern, or the bigger reason for doing this, was kids opening their gifts on Christmas Day and Boxing Day and then starting to use the application in anger. The second driver for them was that they were moving from a startup. They've been around 6 or 7 years. They've grown very well during that time, but they are on the cusp of moving to really quite significant growth globally. So this was the more strategic, long-term consideration about this platform that we've been building organically and iteratively for the last 6 or so years. How well is it going to serve us when we actually move to this next phase in our journey? And as Russell, the principal engineer at CanO, says here, they wanted to pause and put their AWS estate in order. And that was the point at which their AWS account manager said, what you really need to do is a well-architected review, and I will introduce you to one of our partners for that. And that's how we started our journey with them. So what did we do then? So we go in, so a review consists of a workshop with technical and business stakeholders. We run that on site with customers, takes about half a day, and another half a day to prepare some sort of report and presentation back and our recommendations and suggestions for remediation. So we carried that out. And we also, it was a little more wide-reaching, this engagement with CanO, where we looked at the load testing they'd done. And we found some, just a few, to be fair, a few remediations that we recommended to get through that peak trade event. There were some cost optimization things. There were some additional monitoring recommendations that we made. And there were also a few scaling bottlenecks and the single point of failure that was the main engineering remediation that we recommended. And so with the guys at CanO, we then helped them to re-architect a serverless platform using Lambda, API Gateway, and CloudFront. And the news was very, very good. Okay, I don't think I'd be using this as a case study if it wasn't. But they saw a massive increase in traffic across all of their sites, across all of their applications, including the Harry Potter launch, and it was very successful for everyone within the business. Now, looking at the second driver, where we were looking at how is their platform going to serve them longer term as they go from startup to scale up, our recommendations were a bit wider reaching, okay? And so our consultants proposed this platform, this architecture here, which is Kubernetes on EKS. Okay, and this was quite a shift for that engineering team. There were many people within the engineering team that had already started considering a containers-based architecture. And really what we were doing was validating a lot of what they were suggesting themselves and giving the third-party validation for that. And our journey to actually coming up with this with CanO was, again, to run a workshop, involve that engineering team, involve various other technical and business stakeholders, not to mandate that this is the right architecture for you going forwards, but to get that buy-in and to get that common belief that this was the right platform for the future. And what we've pulled out here are, again, we've got the 5 pillars of the framework, and we've listed out some of the benefits, the rationale behind why we would do that. If I just pick a few from there, so certainly from an operational perspective, within CanO, there's a number of different teams working on different workloads, different approaches, different technologies, and bringing the whole organization onto this Kubernetes on EKS architecture provides a unified approach, which then lends itself to greater automation, removing risk across the business, and I think a significant one is also for a business that is going to be recruiting a lot more engineering staff going forwards, having that single unified approach, onboarding new staff and having that common way of doing things is a big benefit for them. Loads of security benefits from moving to the Kubernetes architecture, reliability, performance, and then from the cost optimization perspective, the consolidation, the greater density of infrastructure within the Kubernetes on EKS architecture means that we are estimating that there's going to be around a 20 to 30% cost reduction on top of the use of RIs, which we're expecting to see around a 15% cost reduction in their bills. So that pretty much brings us to the end of this case study. We're continuing to work with CanO as we build out that architecture. We provide them with a 24/7 managed service and provide DevOps engineering for that business as well to continue to evolve the platform. And that is me. If you're interested in hearing more about the CanO story, or if you'd like to speak to us about a well-architected review, we are there, stand B16. And yeah, thanks very much for listening.
Thanks, Phil, for that. So, as you see from that story, you saw the consultative nature of looking at an architecture, working out as a team of partner and customer of how you can improve an architecture. We really emphasize that in Well-Architected, that we're really trying to help people think about how to improve architectures, and we're not trying to look at a way of seeing where people have gone wrong. Because the reality is that as we talk about architectures, the reality is that building good architecture is hard, and we as an industry need to help each other get better. So what have we learned from doing well-architected reviews? I have a few observations there. So AWS itself, as solutions architects, we've done over 10,000 well-architected reviews. So we've looked at over 10,000 different workloads that customers are running on AWS and reviewed those architectures and had conversations with those customers about what's working, what's not working, and try and understand what the learnings from those reviews have been. And of course, we use that as part of the process of improving the well-architected framework. Having these conversations helps us to understand best practices or emerging patterns that are working well for customers. And so the things that we've learned that work well are that doing reviews earlier in your design process makes a massive difference. And one of the reasons for that, of course, is if you think about lean engineering, is that often people talk about the earlier you catch a defect, the less it costs. The reality in technology, software especially, is trying to introduce something like security towards the end of the process is going to be pretty painful. So by doing a well-architected review at the beginning of the design process, as you start to think about how you're going to build this architecture, asking some questions around, hey, have you classified the data that's in this system? Have you thought about how you're going to protect it? Have you thought about the regulations that might apply to this data and how you're going to look after it? Having that conversation early on is a lot easier than to think about how you're going to make that system secure, reliable, etc. The other thing that we discovered is that generally people don't make bad decisions. Maybe this is me being slightly positive, but generally what we see is not that people have made bad decisions, that they decided to do something that was a bad decision, the wrong choice. It's more that they never made a decision, that they neglected to think about something. So maybe you often have that conversation where you look at somebody and say, and are you backing up your systems? And they'll have that look in their face where you realize that they've not actually really thought about how that's going to work. And that's the kind of thing you see when you do a well-architected review, is that people forget to do things. And by having a consistent review process, It's just a way of reminding yourself of how to do that. And the other thing that we see from doing reviews is that most architectures are going to have high-risk issues in them. Now, this may sound like a sad state of affairs for architectures and the systems you're building, but the reality is that most systems that people build have got latent design decisions in them that are not optimal. And by going through a review process, you surface those to yourself, and you can then make an informed decision about where to invest and what you're going to do about those things. So rather than having those things cause you problems at 3 o'clock in the morning, you can actually proactively think about, hey, in the next sprint, as well as doing these features, we're going to pick up this one story where we're going to improve our security or reliability posture or whatever it would be. So being able to understand what the latent issues in your architecture is allows you to make informed decisions about how you address that. So thinking about how we've seen customers use well-architected, and there are many different ways to use it, but the 3 primary approaches that we see are firstly, learning best practices. So when you're moving to the cloud from an on-premises environment, some of the ways that you used to build architectures change. The constraints have been removed, the tools that you have at hand have changed, and what are the best practices for building systems in an on-premises environment are not the same best practices for building in the cloud. So as a technology leader, if you're thinking, hey, I've got teams building things on top of AWS, for example, how do I know if they're following best practices? In fact, what are those best practices? So the well-architected framework documents in one place the best practices for building architectures across those 5 pillars. So it helps you, at the beginning of that journey, know what the best practices are. Secondly, you can use the well-architected framework and the tooling as part of your technology governance process. So as you start to look at systems and think about moving them into production, the well-architected review process allows you to look at that architecture and say, where are there deficiencies in this architecture? As a business, do we want to take those into production? Do we accept those risks? Or do we need to address them before we go into production? So it allows you to make that informed decision about how you're going to do governance in a consistent way, because one of the tricky things with most governance processes is doing them in a repeatable way and making sure that you've covered all the same topics, making sure that you understand where the risks are and how you're going to address them. And then finally is this idea of portfolio management. Most modern businesses are dependent upon the technology stacks that they are running. However, as a business, you don't always have a viewpoint of what that technology portfolio looks like. So how do you know as a business where the risks are in your technology portfolio? What is that technology portfolio? And consequently, where should you be investing time and effort? So using well-architected to understand and document the workloads that you're running, the risks that are in them, and how you're thinking about improving them over time allows you as a business to think more actively about the things that are actually critical to your everyday success, which you may not actually be actively thinking about on a day-to-day basis. In the last 15 minutes, I'd like to cover off 5 takeaways. It's actually 6. I don't know why I put 5, because I started off with 1 per pillar, and then I had an extra one. Probably something to do with the way that I order takeaways as well. But what I want to do is to try and give you 5 or 6 ideas that make you think differently about architecture. So hopefully these are ideas or ways of thinking about architectures that at least one of them is going to be something that you can take away and apply, and it will help you. So the first one I want to talk about is planes of operation. When you're thinking about operational excellence and you're building a back-end system or a service, one of the things that's interesting to think about is planes of operations. This is a concept that comes from telcos and networking. And really what it says is that when I build a system, when I build a service, I think about 3 planes of operations. I think about the data plane, which is what I use to talk to the service. So imagine I was building a database service offering. That data plane would be where I talk to the service using something like ODBC. So that's the data plane. That's the thing that you talk to a resource when you're using the service. And then the control plane, hopefully you're familiar with. It's the API that you would use to request resources from that service. So in the case of something like RDS, those are the APIs you're calling to say, give me an RDS database. And so the control plane allows you to request resources and to specify how they should be configured. And then the third plane, which people don't really talk about too much, is a management plane. And this is the plane that the person running the service or the back-end system uses to manage and operate that system. So this is the systems that are responsible for making sure that that service is available, adding new features, capabilities to it, etc. And the observation I want to make to you is that the code that your operations team are writing today to look after your back-end systems, whether that be to do backups, to configure, to change configurations, to do deployments, whatever it would be, that is actually the top plane there, the management plane. And that's the plane which you should be treating with very high levels of engineering discipline. And unfortunately, we haven't always done that. We haven't really thought about operations code as being really important. And so one thing I'd like you to think about when it comes to operations is to think about your operations code as being actually some of the most important code you have. And it's the code that you should be doing to at least the same level of engineering discipline as the rest of those control planes. For security, I'd like to introduce you to the ideas of playbooks and runbooks. I presume some people have heard of these terms. Anyone put your hand up if you have? Okay. So one of the things I see with playbooks and runbooks is that we all use them to mean different things. So these are my definitions. You'll feel free to use your own. The way I try and remember playbooks and runbooks is that playbook, the P in playbook stands for process, and the R in runbook stands for routine. And so playbooks are more to do with how do we handle situations in a general way? What's my process for handling this? And so, for example, in the case of incident response, you might have a playbook, which is something you've written in Markdown, which tells you when you get a security incident that you should page the security team, contact AWS support, isolate the instances, like take away their security groups, see if there's any IAM entities on that instance that have got rights to create resources, see if there's any like persistence going on. So if those IAM credentials can create EBS volumes, make sure that those you've got understood what's going on there. And so the playbook basically documents how to think about that kind of situation. And of course, you can evolve those playbooks over time as you see what works and what doesn't work. And we have this concept of a game day where you can simulate failures to help you improve things like your playbooks to ensure that they actually work when situations occur. Now, as your playbooks become more mature, you'll start to see some processes happen a lot or they reoccur and they become more routine. And that's when you can start thinking about having a runbook. And with a runbook, what you're actually really trying to do is, when this situation occurs, here is the code that I want to execute. And so in this particular example with incident response, you can have something which is listening to CloudWatch events and looking for anomalies. Can't even say that word. And you can look at guard duty and CloudWatch and CloudTrail and see if there's anything happening that you don't like. And if you don't like that, you can trigger a Lambda function that does all the things that you were manually doing in the playbook before. So you can see how runbooks effectively allows you to move from a process of trying to do things manually to having something that you can do in code. And of course, one of the advantages of doing things in code is that you can test it, iterate on it, improve it, see how it's changed. And often when people talk about runbooks and playbooks, there's a sort of gentle pushback of we haven't got time to do that. What you'll find is that you can apply runbooks and playbooks to multiple systems. So as you build these become things that you can use in many different places and many different systems. And as I mentioned before, they become part of that management plane of your system. For reliability, I'd like to talk about recovery-oriented computing, ROC. Who's heard of that? So this is a bit more niche. So recovery-oriented computing is really about changing our mindset from mean time between failure, trying to minimize that, to focusing on mean time to recovery. How do we allow our systems to recover more quickly? And it's kind of like Werner Vogels would say that everything fails all of the time. If you know everything fails all of the time, then you can put some effort into trying to stop those failures from happening. But what's actually more important is how you respond to the failure and how quickly you can recover from it. And so when we're building systems, we tend to do a form of testing which is testing the happy path. The happy path in any system is the code that executes when everything is working fine. And when you talk about testing, you'll see that most testing strategies will say, let's test the system works. Does it deliver the features that the users want? And of course, that's an important thing to do. You do want to make sure that it delivers on the expectations of your users. But of course, you will find bugs in there. And when that happens, you'll write mitigations that will try and fix that. So you'll say, hey, when this error occurs, let's do this thing to get us back on the happy path. And that's generally how most systems are built and tested as well. The issue is that when I read most root causes analysis, so when you're looking at what causes most failures, when you look at news articles about various organizations where they've had an outage of some sort of a security incident or whatever it would be, you find a reoccurring pattern. And the pattern goes like this. A failed, and then the mitigation for A failing failed as well. And it happens constantly. And the reason for that is because no one tested that failure pathway. So the clicker was now failing on me, which is really helpful. So the takeaway on recovery-oriented computing is to think about that untested paths will fail. So in your system, if you don't test those pathways, they will fail, because the first time you run that piece of code or that process, it won't work because no one's ever tested it. And so as I mentioned before, you can use game days to address this. So an idea of a game day would be is that because you've got your systems defined as infrastructure as code, you can bring up a duplicate of your application, service, whatever it would be, and then you have somebody who understands that application or service introduce a problem into it. But you don't tell your team this. You tell them, we're having a game day, we're going to cause a problem, it's going to happen sometime today, I'm not telling you when it's happening, and I'm not going to tell you what I'm going to do. And the idea is that your team, firstly, the first thing they normally spot is they haven't got sufficient diagnostics and monitoring to tell them what's working and what's not working. So it helps your team to understand have they got the right tools. Then when things go wrong, they actually know that they then need to fix those things, and they get to work out whether their playbooks and runbooks actually handle this correctly. And what you'll see is that as you execute game days, that your systems will become more reliable, because the things that were going to go wrong without testing are being found and being fixed. So game days are a way of you not only finding out the errors and the problems in your systems, but also building organizational memory of what to do when things go wrong. And one of the interesting things about building high-quality systems is that the better you get at building these systems, the more reliable, the more secure they are, the less chances you have to learn about what happens when they go wrong. So you need game days to offset that. In performance, Deming cycle is your friend. This is the plan, do, checked, act process. So if you've got a system that you're thinking, hey, I would like this system to be performing faster, it's just not fast enough, or it's not reliable enough, it's not secure enough, whatever that metric is that you're concerned about, you can use the Deming cycle to target how you improve that. And really the Deming cycle is about saying, how do I take a process and how do I improve it? But you can apply that exact process to any system. And on AWS, you can approach it this way. So you can, first of all, pick what you want to fix. So you're going to say, I'm planning to reduce the execution time of this particular system. So maybe it's a batch process. Because you defined your infrastructure as code, so you've got a text file, such as CloudFormation, that defines your infrastructure, the networking, the load balancers, the database systems, what types of EC2 instances you're using for different things, how you're using queues, SQS. This is all defined in code. You can take that code and you can check it out, and you can say, let's see what happens if we use one of the newer EC2 instances. So you go into that CloudFormation, you change in the CloudFormation where it specifies the instance that's being used there, and then you trigger off your build process. And of course, if you're following well-architected, then that will be a continuous delivery process. So CI/CD takes the code, creates an environment, deploys it onto it, runs some load tests for you, and then you get some metrics back. And you can look at those metrics and say, what do those metrics tell us? Do we actually get what we wanted? Is the system faster now? Did it do what we want? Of course, we're also thinking about, has this introduced any reliability problems, or has it changed our security stance, or has it changed the cost of the system? Are we happy with the balance of those things? If I am happy with the balance of those things, then I could check that change back into mainline, and then the next time we do a production deploy, we'll have a slightly faster system. And of course, you can iterate on that and you can keep moving forward. And one of the things you find when you look at systems where you're trying to improve some sort of KPI is the reason that people generally don't do it is because it's just too hard, it's too risky. So when you can do it in a separate environment in a risk-free way, it really sets you free and allows you to think about how can I improve that architecture. And of course, that also makes running game days and things like that much easier. Cost to me is always a tricky one. Who here has had some form of technology education, like who's done like a degree or something like that? Anyone done one of those? Okay, and in that, did it cover security? Put your hand up if it covered security. Okay, now put your hand up if it covered cost. Did it, anyone? So one of the problems we have is the vast majority of training courses and education around technology, architecture, etc., does not talk about cost. And it's a bit like the Sapir-Whorf hypothesis of if you don't have a name for something, you can't think about it. Because none of us have ever talked about cost, we have a blank space in our head when we come to thinking about this. When you are on an on-premises environment, it's really hard to say, hey, I don't need these servers anymore. Can I have that bit of the budget back? Now, of course, when you move to the cloud, that's actually possible. So one thing to think about is, firstly, most of my team who's building a system don't think about cost. So think about mechanisms that you can put in place to make sure that everyone is thinking about cost. So if you have a dashboard, maybe have a KPI, which is what's the dollar cost per request of this system. And think about what is the value being delivered. So when we talk about cost optimization, it's not just thinking about how do I reduce my AWS bill, it's also about how do I make sure that I'm delivering good business value and balancing those two things out. And so when you're thinking about cost, think about, firstly, that most of the team probably aren't thinking about cost, and we need to make sure that everyone is thinking about cost, because ultimately, as AWS, we actually want you to spend less on your architecture so that you can use that money to actually have more developers or more people in your team adding value. We don't want you spending stuff on resources you don't need. And my bonus takeaway is the well-architected labs. So we have on GitHub put a bunch of source code that tells you how to do various things to be well-architected. And we did this because we wanted to give you some executable content, something that you can do in a short period of time. You can go into the labs, find a concept you want to learn about. You can check out that source code, play with it, work out how it works. You can use that source code, obviously, to implement into your own systems. But more importantly, it gives you a place whereby you can see how the well-architected team would go about implementing these kinds of approaches. So the well-architected labs is obviously available on GitHub. I'd really recommend you go use it. And if you've got any feedback you want to give us, please submit some pull requests as well. So with that, if you want to get started with well-architected today, I would say, as with most things on AWS, just roll your sleeves up. We have online resources that will explain to you what the well-architected framework is. We actually have free training as well. We have white papers and Kindle editions that you can read. We also have partners and your account teams who can actually help you thinking about how to get started with well-architected. But more importantly, we built a self-service tool which is free, which is an educational environment, so you can start using it and it will help educate you as you go. And with that, I'd like to thank you for your time and just ask you, firstly, if you can use the app to give us some feedback on how this session went, and secondly, to say that we've got some free swag at the door, which is not meant to be influencing the vote that you're giving in terms of how well the session went. With that, thank you.